What if I told you the oldest government computer still running isn't in a secret lab or military bunker, but floating 25 billion kilometers away in deep space? This tiny machine, built in the 1970s with less power than your pocket calculator, is still sending signals back to Earth. Meet the Voyager spacecraft, humanity's most distant messenger. Built in 1977, these computers were designed at a time when personal computers were barely a thing, and the internet didn't even exist yet. And yet, nearly 5 decades later, they're still doing their job. When NASA launched the Voyager spacecraft more than 40 years ago, they weren't powered by anything close to today's cutting-edge tech. In fact, each spacecraft, Voyager 1 and 2, carried just 6 computers designed by General Electric for NASA's Jet Propulsion Laboratory. The computers consist of 3 types: the 18-bit Computer Command System, CCS, the 16-bit Flight Data System, FDS, and the 18-bit Attitude and Articulation Control System, AACS. And here's the smart part. Each one was duplicated, so if a computer failed millions of miles away from Earth, Voyager had a backup ready to go. Now, here's the crazy part. These computers are hardly cutting edge by today's standards. To give some perspective, the processors aboard the Voyager spacecraft operate at just 250 kHz, far slower than the processors in modern smartphones, which run at speeds of over 1 GHz. According to NASA, a typical instruction on the Voyager computers takes 80 microseconds. That is about 8,000 instructions per second. To put this in perspective, a 2013 top-of-the-line smartphone runs at 1.5 GHz, with 4 or more processors yielding over 14 billion instructions per second. The computer's storage is perhaps even more strikingly outdated. Each spacecraft carries an 8-track digital tape recorder with a capacity of only 68 kilobytes. For context, that is roughly the size of a single JPEG image. Despite this limited capacity, NASA engineers have ingeniously developed methods to maintain a continuous flow of data. As new data is received, it overwrites the old data, ensuring the spacecraft's limited storage is always in use, and that valuable data continues to reach Earth without interruption. Despite its minimal capacity, this approach has allowed Voyager to successfully capture and transmit images and scientific data throughout its journey across the solar system. One of the key achievements of these systems is their role in transmitting images from distant planets, such as Jupiter and Saturn. To manage this process, the spacecraft's flight data system was designed to transmit images at different data rates. For example, a full-resolution video from Jupiter was transmitted at a rate of 115.2 KB per second, taking 48 seconds to read out a single frame. For Saturn, the process was slowed further, allowing scientists to receive detailed images despite the slow data transfer speeds. Over the decades, Voyager's computers and systems have required careful adjustments to remain operational. While no new hardware can be added, NASA engineers have continuously updated the software and reprogrammed the spacecraft from Earth. These updates include modifying how instruments operate, adjusting power usage as the spacecraft's energy supply declines, and even rerouting functions between redundant systems when failures occur. In essence, the spacecraft has been gradually reconfigured to conserve resources while still collecting and transmitting data. At one point, Voyager 1's flight data system began transmitting incoherent information back to Earth. The issue was traced to a corrupted chip that could not be repaired. Unable to repair the corrupted chip, NASA's team came up with a creative solution. They divided the corrupted software into smaller parts and redistributed those sections across the spacecraft's memory. References to the original code locations were then updated throughout the system. This complex reorganization restored the spacecraft's ability to operate correctly and continue transmitting usable data. These updates are an example of the ingenuity required to maintain such an ancient and distant piece of technology. The system's continued success can also be attributed to the highly reliable backup systems in place, ensuring that even if one computer fails, others are ready to take over. Despite being located over 167 astronomical units from Earth, about 15.5 billion miles, the spacecraft's systems remain operational, continuing to transmit valuable scientific data back home. More than 4 decades after launch, the Voyager spacecraft continue to defy expectations. Their ancient computers, limited storage, and carefully managed systems have carried them farther than any human-made object has ever traveled. Voyager's journey is not just a story of technology, but a testament to human curiosity, engineering, and persistence. Even as their power slowly fades, these spacecraft remain our distant messengers, sending back knowledge from the edge of interstellar space, a reminder of how far human ingenuity can reach.